Hello friends, welcome back to my video on data science. In today's video, we will look into some of the very useful Pandas functions. Uh, we will use the simple data set to explain the some of the function which we have not heard about it or very rarely used. So let's get into the code. So what I'm going to do here is I am going to use some of the basic packages like C1, Pandas, sklearn, and NumPy. And then what I'll do, let me run this. Okay. Then I do need some other data set like tips. Tips is basically the tips given in the hotel. So we have that data set first, and it's a part of our. Then let me take some of the data set like tips. And I'm also going to make use of the very famous data set called breast cancer. So these two data sets, will be playing around with this two data set, and we will see some of the very useful function. First, let's load this two data set. First, see what is there in the tips. Under the tips, what you can see, you have a total bill amount tip, the gender, this whether the person is a smoker, and which day the person visited the hotel, what is the time, whether it's a breakfast, or is it dinner, or is it supper, and how many people visited, and what was the tip given. Then the second data set that we are going to make use is the breast cancer. So first let's get into the data set. Look into some of the data features of breast cancer. So we have all the mean values here and standard error. So we could see radius, texture, perimeter area, smooth, and everything. This is all related with your tumor, the tumor, breast tumor, that is part of your breast cancer data. I'm not going to get into this the details about this data set. That is not the purpose of this video. The purpose of this video is learn some of the very rarely used but very useful Pandas function. So this is the data set which is from the UCI machine learning. You can read about this. So you give the describe the data that describe, and you'll get all this information. Let's go to the other one. Okay, this is about loading this data set again, because the breast cancer data set is not in a data same format. So we have to add the feature names, and then we have to add the target column as well. So once you load this, you will see that like all the 30 features here and the number of rows. So first 5 rows is getting this. Okay. So wanted to show the mean radius between 15 and 20. So between function is the one which I'm going to make use of it. I'm going to use the breast cancer data set and get me all the result that where the mean radius is between 15 and in between 15 and 20. And so show and give me the first 10 rows of it. So here you can see once I run this, okay, let me change this value to 20, 30. So you can see here the mean radius between the values between mean radius 20 and 30 is getting displayed. So how this is useful? In your data set, there could be thousands of rows or maybe millions of rows, but you wanted to get only those rows which are between the range that you might be interested. So this is the one example that you can see. Second one is the T function. T function is basically is a transpose function. Is we'll see with one of the example here. Okay, I'm not going to use this. Okay, so normally when I do tf.describe, I get all the column on the top, and I get this count, mean, standard deviation, and this percentile and other min and max in the an index, or maybe on the left side the row. But in some cases I may not be interested. I might be interested in seeing these values in a other format, so transpose format. So the T is nothing but the transpose. So what I'll do is I'll just type describe.p, and you could see that there is a difference between. So now you can see that all the columns became rows and rows became columns. You can see all the mean radius, mean texture, mean perimeter, mean area, mean smoothness, everything. Then whatever you saw here, the row format, that became as a column. So this is how, like, this is a one useful function where you can transfer the entire data frame, the rows into the column and columns into the rows. This is a very useful function. But let us see some of the other functions also. The third one that we are going to see here is the Pandas styler. So like if you work in HTML, like you might aware of the style sheets. Similar way, Pandas also has a kind of a style sheets, inbuilt style sheet which you can make use of it. So normally, when will I use this style sheet? So let us see an example here. So in my example here, I just said df.head and I'm printing all the first 5 rows. But some cases, let's say I take the mean radius and I want to give some color code based on the highest to lowest. Or I may take mean texture and I want to give some color code based on the highest value to lowest value or lowest value to highest value or anything, any statistical function like mean or median or anything. So based on that, I want to give some background color to this. So to do that, what you can do is you have a function called style. You suggest this dot style and background gradient. This is the function here. So you call this and then you say subset equal to the column names. So mean radius, mean texture and texture area. So and then you give the C map is equal to blues, or you can give any other color. I'll show you how to get the other colors also. There's a dirty way to get the other colors. So you can see here, like you will get the numbers based on the background gradient based on certain conditions. So you could see the highest value is getting darker blue and the lowest one is getting the lightest blue. So similar way you can, if you want to change it to so red color pattern, you can just say reds. You might be go to reds. You might be wondering, okay, I know blues and reds, but I want to give some other. How do you do this? So there's a dirty way. Just give some wrong value here. So instead of capital R, you just put small r here. You type here. So what you get is that you get an error here, but it will also give you that the supported values. So you can take any supported values from here. So let me take a supported value which is cool R or cool warm. Okay, let me take this. Now I know the school worm is a valid value here. Take this, I paste it here. So you can see you get a different color here. So this is how, again, this is not the right way, but again, the easiest way to do it. So to see what are the other values, CMAP values here. So this is the style sheet that you have provided. So in similar way, you can add more columns here. Say for example, I want to add an area error here. You can copy this area and then the you can see here. So you get the color coding here, background color. And this is not the only option that you have. You have many other options. So like you can go to this pandas pydata.org and then reference style.html and you can get there are multiple options available here. I just provided the links here. So you can click on this link and I'll also share the notebook. So in the notebook you will get this link. Once you click on this, you get to know about what are the other options. This is only one example I have given, but there are multiple things so that you can play around with this type. Okay, the next useful function that we are going to see is the convert data type. So this convert data type, how many times that you have seen that the data type is wrongly mapped to object? So let's say that you have 30 features in your data set and there are about some 20 features are wrongly mapped to object and you want to infer the value, and based on the value inference the data type has to be changed. So to do that, one way is the manual way, like you can change you can put as type and you can change it one by one column. But let's assume you have hundreds of column and out of 100 column 40 columns you want to change. So in that case, like it's not that easy. So wherever you have an object, that has to be um, given back to proper data type like float or category or int. In our case, we don't have any such, but I would like to explain this. So first, to know that what type of data types we have, I'm going to make use of this tips.data types. Okay, so I do have float, category, and int. I don't see any object here, but if you have object, like the next line will give me a better visibility on the functionality. So you can see the tips dot convert dt types dot dt types will change the object data type to a correct mapping. To say, for example, I have float, but somehow it is being mapped as a object, that will be changed to float, or maybe int, if it is being considered as an object, that will be changed to int. So this is one of the useful function, like where which can save you a lot of time, and this will be very useful in your pre-processing, data pre-processing. Okay. Second one is the select data type. The select data type again is very useful function. Let's say you have multiple features, and out of which you have a category, like just like take the example of category, int, and float, and then you have other string, maybe string features and other things. So what you want to do is, you don't want to select this category, rather you are interested only in the numerical data. So all you can do is, you can say select underscore dt types include np.number. Then you just say what you see. It will show you only the numeric data types, and it will print it over here because I have given it. So this is a very useful function. This will again definitely save a lot of your time, because all you need is a number, but again selecting one by one will take a lot of time for you. So again, this is a small tip which will help you to save a lot of your time. Then the mask function. So let's say that, let me consider the example. Let's say I have some outlier value where I want to fix those outlier value, or maybe I want to exclude that outlier. Rather, exclude is the right word I should have used. So I want to exclude that outlier value. So for example, uh, in this case, the total bill. So the total bill, I am interested only in the total bill which is between 10 and 60, and I'm not interested in the other values, other rows. So anything less than 10, I'm not interested. Anything above 60, I don't want that to be there for my further analysis. So all I can do is the data frame dot mask and condition equal to not equal to the tips total bill between 10 and 60. So this is the negative function I'm giving here because I added a tilde symbol. You can see a tilde symbol here. So I want to consider only the value which is between 10 and 11 and 59. I don't want to consider anything lesser than 10 and more than 60. So once you see, you get only those rows which is having less than 60 and sorry, less than 10 and greater than 60. So very useful function, mask function, to exclude the outlier. Mm, the next one that we are going to see here is the n largest and n smallest. So this is very useful function, because often you may wanted to see what are my top 5 values, or what are my bottom 5 values. So in this case, you can make use of n largest and n smallest. In this case, I'm going to show the top 5, but you can change the number to any number. So I want to get me the bills, so my top 5 bills for the day. So I can say the data frame dot n largest. I say 5. So let me say top three bill amount. So these are my top 3 bill amount. You can see that the first the maximum value is $50.81, and the third largest is my 48.2. Similar way, you are interested in getting the bottom 3. So you want to see that which are those customers who paid the bottom 3 bill amount for the day. So you can get very easily. So you can see that this is the lowest value, and then the next one lowest is the 5.7. The third one is 7. So very useful function, the largest, because very often we might use min and max, but that will give you only the minimum value and the maximum value, but it will not give you the nth largest or nth. So, and you also have the option to change it. So you can say from 3, you can say top bottom 10. smallest. Similar way you can say. You can change this parameter value and you will get those values. These are my top 10 values. These are my bottom 10 values from. Okay. So the next function that we are going to see is the at time and between time. Very often you want to play around with the time value. So let's say that you want to show me all the transaction that happened between a particular given time period in a day. So let's say that I'm interested in seeing the value between the 12 noon to 3 p.m. So in that case, how do I get those data? I mean those data from the time. So do that. I have at time and between time function in Pandas, very rarely used. So I'm creating a data set here, just a series of data set because I don't have any time series data here, and this is based on the hourly frequency. So once I create this, so you can see that I have like 100 rows I have created, and which is 100 in the frequency is hourly frequency. So now I would be interested in getting the what happened. Show me the rows. Like I want to know that every day at the 15th hour, what happened at the 15th hour. So I can just say, so you'll get the value like what happened. Maybe if I change it to let's say 18, I get what happened at the 6 p.m. So 6 p.m. I could say that maybe the number of customers instead of column. Okay, let me first. So now I want to interested like how many customers visited uh, every day at 6 o'clock. I could see that on August 1st it was 18 customer and August 2nd was 42. Then August 3rd it was 66 and August 4th it was 9. So gradually it is increasing. Again, this is a dummy data set. Doesn't mean anything here, but again, just for your understanding of just for to make you understand about that time, I'm using this. So moving forward, there is another function called between time. I want to know that what happened between 9:45 a.m. and 12 noon. So I can always say that data dot between time. Between time is a part of your datetime function. Like you have to import the datetime. Then you can say that data frame dot between time the lowest value and the highest. Run this, you see that okay, you see that every day between like 9:45 to 12:40, 12 in the like how many customers. So on the 1st of August, you could see that there are 10 customers at 10 o'clock, then 11 customers at 11 o'clock, 12 customers. Then again the 2nd of August, 34, 35, 36, this 58, 59, 82. Again, this is a random number. So don't worry, but when you implement this in your real data set, you'll see uh, the real use of this one. The another one and very useful one is the autocorrelation. Autocorrelation is basically like whenever if you worked on the time series, basically you want to see what is the autocorrelation between my I take the example. I have a sales data set, and every day I'm tracking my sales. So I want to know like is there any correlation between my yesterday's sales and today's sales? So that is what is called as autocorrelation. So normally in cross-sectional data frame we see the correlation, but in this case autocorrelation is basically based on the lags. So what is this lag value? So lag of 1 is nothing but yesterday, lag of 2 is day before yesterday, and it goes so on and so forth. So if I want to know like okay, is there any correlation between my uh, last week same day and today's sales? So what I can do is I can always use a functionality called lag function. So I'll say autocorrelation against the pandas function, autocorr, and lag of 1 means I'm saying that I'm just looking the correlation between yesterday's sale and today's sale. So in this case, I'm using this tip here. So and also this data frame, you need to understand this tip database is at hourly level. This is at the hourly level. So basically, so you can say that autocorrelation lag of 1 means 1 hour before prior, and lag of 2 is 2 hours prior. So, so I'm just saying that in my previous lag, the previous hour and my this hour, is there any change in the tip? So tip amount that I received. So, so the correlation is a very low correlation. Though it's a positive correlation, but it's only about 3% of correlation between the previous hour and this hour. Let us move to these 2 hours before and see if there any correlation. So I can see that, okay, again I could see it's better than the previous hour, but again it's a 10% correlation between previous hour, the previous 2 hours and this. Similar way, lag of 3 is 3 step I mean back, 3 step back. So 3 hours back, what happened? So again, I could see again it's about 9%. So similarly, I can give any values here, and I can see the correlation between everything. So basically, this will help you to understand the correlation between the current value and the lag value. Okay, with this come to the end of this very useful Pandas function. Please try this out. Let me know if you want. Let me know your feedback and such. Thanks for watching. Have a good day.